I don't know if we need to turn anything in, but just in case. We should do it. Okay, so question 1 again.
This is for one. We're doing this. I'm still trying to figure out. This is vectors, right?
Yeah.
Okay. I think I'm doing this right. Hold on.
So I'm just drawing an arrow going to the right because it says it's going west. And then once you reach a certain point, you will encounter water flow with a velocity of 6.2 miles per hour. So we need to do something with the velocity. So in my mind, I think I'm going 3 miles, and then at a certain point, you're kind of going up, right, to velocity 6.2.
Yeah.
So I think we need to set it up some way that we can do the horizontal and the vertical components. We need to figure out if there's a way to figure out the angle from where it goes up.
Well, does it say we're moving directly west?
Yeah, it says you want to swim from one side of a river to another. Assume your speed is 3 miles per hour in the west direction.
So if we draw that out, it'd just be a 90-degree straight to the left. And then once you reach a certain point, you'll encounter a water flow with a velocity of 6.2.
In the north direction.
In the north direction. So would the angle just be 90 degrees? I don't.
I'm not sure. Still trying to figure out how we would approach this. Any ideas, Antonio?
I'm drawing out. I need a new paper, but I'm drawing out just plotting some points on the graph, and I basically just did 3, 0, and then 6.2, 0, and so it's just the 2 square lines. But I don't know if you just have to find like the subtracted or what it is that we should do there. I can't remember how.
Yeah, so let's see. The question: what is your resultant speed and direction?
So we're looking for a magnitude and an angle.
Mm-hmm. And so it kind of needs. We use those 2 points that were given to find. Did you say O?
Don't you have to? So I think you have to add the 2 points, those 2 points, and then get the magnitude by getting the square root of those 2 points. Once you add it, square them and get the square root of them, and that's your magnitude. And then the degree, I remember this. I just did the homework on this.
Right.
And then once you have that, you take what was it? It depends on which quadrant it is, and then you have to take, I think, the tangent of it, or is it?
Oh, so to find the direction angle.
Oh, it's
you do the y value over the magnitude, right?
So you have the 2 points, 3, 0, and 0, 6.2, and you add those two, so you would get 6.2, and you would have r magnitude equals square root of 3 squared plus 6.2 squared, and then whatever that is, it's 3 squared is 9, square root of 9 plus 6.2 squared. That's 30.44. So it's plus 9. So r would equal the square root of 47.44. So that would be your magnitude. And then to get the angle, you would take the b part of the so y over that magnitude.
And then the inverse of sine, right? To get the angle?
I'm not sure. I know on the
yeah, I think
on the homework, I know that some of them were sine and some of them were tangent, but I couldn't figure it out because it would always switch on me, and I thought tangent was only if it was on quadrant 1, but then they did it on quadrant 2 as well on the math homework. So I don't know what you would do.
I think it's fine because we're using the y, but then I think we have to look at what quadrant it is, because
yeah,
based off of the terminal point is how you, like, if you need to subtract it from or plus it from 180 or whatnot.
Yeah. Well, after you get that, after you get the inverse sine or tangent of that, you have to add 180. Or
Only
I guess
if you
depending
can
on the quadrant.
Yeah, but since this is kind of, I think this is in quadrant 1, right? Because they're both
Yeah.
positive numbers. So I think if okay, so let's do what's y? It's 6.6.
6.2, yeah.
So 6.2 divided by the sine of 40, or the square root of 4744, and we have to take the inverse of that. So inverse, we're doing the calculator. 6.2 divided by square root of 4. I got 64.2 degrees. I don't know if anybody else wants to about that.
That's what I got.
You said 64.2.
Yeah, that's what I got.
Okay, and then so then you would add the 180 then to that.
Because it's in quadrant 1, we don't need to add 180 to it.
Oh,
But I might be wrong, like does anybody else? I think since it's in the first quadrant, you don't have to do anything. I think it's the one that's in any of the other quadrants that you have to add.
I'm gonna
to
check.
it.
I'm gonna check my notes because I think I don't know why. I think you still have to add it, but let me just check.
Okay.
Because normally I get a negative. Oh, that's why. It's not. So it's not y over magnitude. It's y over x. That's why.
Oh, it's the tangent instead of the sine.
Yeah.
So the inverse of tangent of y over x.
You would get the same thing.
So maybe it works both ways for quadrant 1.
Oh, this is what it says. If x is greater than 0, then theta is equal to tangent, inverse tangent y over x, or if x is less than 0, x is not less than 0 though.
I got the same answer too. So maybe for that one it works the same.
Yeah, I think so.
Okay, so now we need to, so we have.
So let me write this down because I've just been making a mess on this paper. Wait, so what did we do? Forgot. Okay, so sorry, I'm not fast at writing these out.
Oh, you're good.
And then- How would you write that? It's just
So I think now that we know the angle, or we at least know the direction, but the resultant speed is where I'm having a hard time figuring out. Like, I think that's where we need to do the horizontal and the I'm gonna find it. Because if you're going west and then you start going, we're going 64.2 degrees, that would be northwest, right? But the speed, I don't know. Is there an example of this in the textbook?
I don't remember one. I'm actually wondering if, because you're heading west, but you're getting pushed north, if you're basically just taking the 3 miles per hour that you're going, and multiplying that by the 6.2 miles per hour that you're being pushed, and that would give you the resultant speed, and then the direction would just be northwest.
The only thing is, I think if there's velocity, it makes it go slower, right? Because it's encountering. Or sorry, say that again. You said 3 miles an hour.
If
Oh.
you go,
I think the magnitude is your miles per hour.
Yeah. Oh,
So
but the like 6.2, or is that what you're saying?
the square root of x and y, so r, your magnitude, I think that's your miles per hour.
Oh.
oh,
So 6.88. If you like did a,
I'll put. Should I use round up or?
yeah, 6.9. I don't know.
I'll just say the resultant speed.
6.9 miles per hour. And then going at 64.2 degree direction. Does that make sense to everyone?
Yeah.
Direction, so northwest, 64.2 degrees. Okay.
Number 2, Antonio, are you ready, or do you need to write anything down?
I think I got it all.
Okay. So question number 2, write an equivalent rectangular equation for the polar equation r equals 10 over 3 sine of theta minus 7 cosine of theta.
These ones are fun.
So these ones I'm still shaking on because I just haven't done a lot of them.
So I feel like you start by multiplying the denominator in that equation by across the equation, so it's r times. So you just have you separate 10 from the other side. So you have 10 equals r times 3 sine theta minus 7 cosine theta. And then
Okay. All right, so get the we need to put times it by the 3 sine to get 10 on the other side, so it's all in the linear equation.
yeah.
Okay, so r times 3 sine of theta minus 7 square theta equals 10.
Yeah, and then you multiply r out, and you get 3r sine theta minus 7r cosine theta. And then you could do, so that would be 3, his sine y or x?
Sine is y.
So 3y minus 7x, right, equals 10.
Which one do you want to have on what side? I know on the homework on my math lab they had y alone. Should we just move the cosine over first to have the x on the right side and the y alone on the left?
Like after we distribute out the r, you mean?
Yeah, right after that.
Yeah.
I mean, yeah, we could do that. So it's 3r sine theta equals 7. Oh, it'd be positive 7 r cosine theta plus 10, right?
Yeah.
And then you put that into x and y. You get 3y equals 7x plus 10. And then you gotta get y, and then you gotta divide by 3. I feel like that's it, right? So y equals 7x over 3 plus 10 over 3. Or did I do that wrong? Does that seem...
What did you say you got?
Y equals 7x over 3 plus 10 over 3?
I would just keep it together. I would just say 7x plus 10 over 3.
Oh, yeah. Is that what you got too?
Yeah.
Yeah.
Sweet. Okay. So it wants us to put this into a rectangular equation. Nine tangent theta squared. So do we want to start by taking the square root of each side?
Sorry.
Right? Would that work out?
Yeah, I think we should move the square from the right side over to the left, because I can't remember what the square root of x squared plus y squared equals.
That equals r squared.
That equals r squared. No, I think that just equals r, doesn't it?
No, I'm pretty sure it's r squared. I have it in my note. We're allowed to use notes, right?
Yeah, we can use
I think so.
notes.
Well, I hope so, because I've been using notes. You may only
Yeah,
use
like
your
before.
Textbooks notes. Okay, you can use
Okay.
notes.
You use your textbook notes and calculator.
Here, let me pull
All
up.
right.
I think I have it written down in my notes. Let me just grab it real quick. Yeah, so it's r squared
Oh.
equals x squared plus y squared. And then r equals the square root of x squared plus y squared. So if we take the square root of, or if we take the square root of the both sides of the equation before we move anything.
So x squared plus y squared, that's equal to r squared?
Mm-hmm.
Okay, I'm just gonna write that down real quick.
So if we do, and then the y over x is tangent theta. So I think if you take the square root of both sides, I think you could solve it out. I don't know. So you get r. That would be square root of x squared plus y squared equals square root of 9 y over x. So you could get rid of squared, and then the 9 would go to 3, I think.
I'm gonna try to look up in the textbooks see if I can find anything too.
Yeah, so I think just on the right side alone, you can make it 3 times y over x. So there'd be 3 tangent theta. And then you can make, and then you square it the other side, so there'd be r. Right, and is that what we're looking for? I think, yeah. Would that work? Did you guys follow me on that one?
I think that's it. I don't know if we can do anything else.
Yeah, I think that's just it.
Because when you go from polar to rectangular, x is r cosine theta and y is r sine cosine theta.
Wait, what?
Well, I was looking at this. Is that polar to rectangular, x equals to r is r cosine theta and y is r sine of theta?
So,
yeah, but square root of x squared plus y squared equals r. So if we square root both sides, then we get r on the left side, and then the other side we could just solve out, because y over x is tangent theta, and if we square root it, it gets rid of that square, and then the 9 turns into a 3, so it'd be 3 tangent theta. So what I think is the final answer is r equals 3 tangent theta.
Yeah, I think that's right too.
Okay. Cool.
Because even if you did it the long way would just be you get rid of the square root on the right side by or the square on the right side by doing the square root on the left side, and you would get the square root of x squared plus y squared and that would just equal R.
Yeah.
So it would just,
both ways.
or actually, wait a minute. Oh yeah, you would still square root the right side and the left side, and so you would just get R. Yeah, it's just faster, or the same process to get to R equals 3 tangent theta.
Okay, cool. Should we go to the next one then?
Yeah.
Write an equivalent polar equation for the rectangular equation x squared plus y squared equals 9 times y over x squared.
I know that's the one we just did.
Yeah, I think you just read the same one.
Then we didn't do that one that I said. It was r equals 10 over 3 sine theta minus 7 cosine theta. Maybe that's why we're confused.
We did 2.
No, we did do that one.
Yeah, it was y equals 7x.
7x plus 10 over 3.
Yeah. Yeah. Do you have what's huh?
I'm so confused because I thought that was the one we were working on.
Oh.
We did the first one, the one with the miles per hour up the first one.
Right.
And then we did the r equals 10 over 3 sine theta minus 7 cosine theta.
What was the answer for that one then?
That one was
Y equals 7x plus 10 over 3.
yeah.
Oh, sorry. I don't know where it was. Okay, so you already did that one. So then we're on number 4?
Yeah.
Yeah.
Okay, sorry guys.
You're good.
So graph the polar coordinates 4, 4 pi over 3. An ordered pair in polar coordinates names a single point. However, the coordinate is not unique. Name 2 other polar coordinates that are located in the same place as 4 over 4 pi over 3. I'm not doing this one. Couldn't it just be anything in any of the quadrants? Because they're, it's like the circles, like the targets.
I know that 4 doesn't matter. That first 4 does not matter at all. It's just the 4 pi over 3 that matters.
Yeah.
But I can't remember what you do with it.
Because isn't it like the graph has the rings around it because it's the polar, and it was on that so one of the examples with the first ring. Could it be any of the quadrants in that first circle?
It can be any of the I can't, let me look at my notes real quick because I know that on the homework they had they had a graph and they had all the circle and it went through a certain point, but you had to decide which quadrant it was in, and that's where the point was, and then you can basically use any point on that
thing.
Yeah.
It said we can use it technically, right?
Yes. Yeah.
I'm not seeing it in my notes, so. Because if you don't do, if it's just based on the angle, could it just be same place? So wouldn't it just, you go to the next ring and whatever x is, it would be that plus, and then the y coordinate stays the same? Because it's just based on the angle? I'll just look it up. I'm not sure.
Should we just graph it first?
Yeah, that might help.
Oh, never mind. That 4 does matter. in graphing it, it has to be on the 4, but you just have to draw those lines around the number 4.
So this example, and I'm just saying what it says in the book. It says, so for a point, -2 over pi over 4 is the same as 2 over 5 pi over 4, or 2 over -3 pi over 4. But I don't know how to get there yet.
Wait, what was that?
So this example in the book, it says the point -2 over pi over 4 is the same as it says or 2 over 5 pi over 4 or 2 over negative 3 pi over 4. So now I just need to figure out why. I don't feel like the book is giving a very good example. It just says any ordered pair names a single point, but the coordinates of a point are not unique. For example, it was that example, but it says they're all on the same point, but then it doesn't go on to explain.
Does it have a chart where it says like the degree and then R and then different and then different values for R?
Yeah, well, it says graphing a polar equation, like theta and R, and then 0 and 2. But
I'm trying to find.
It's in.
What page is it on?
I'm looking at 536. I wonder if we need to take the coordinates and do the convert x and y to polar coordinates and see if that we can that r equals square root of x squared plus y squared. Oh. So find an angle that satisfies tangent theta equals y over x and goes through xy. Remember the angle inverse is between pi squared and negative pi squared and pi squared, and we'll go through xy only if x is greater than 0. If x is 0, then the point xy is on the y-axis, and theta equals pi squared, or theta equals negative pi over 2 is appropriate. So I think we do have to graph it. So let's graph it, and then let's see if we can.
Oh, wait a minute. So I'm sending you a picture of what I had for my notes. Basically just copied what the homework did, and I'm not sure if this makes any sense or not, but what they gave us, those are polar coordinates, right?
Mm-hmm.
So on that picture that I sent you, there's some ordered pair, or sorry, they made their own polar coordinates, and they basically just put R, and they changed it, and they gave several different points, and then they kept theta the same. So it would be like, I think it's like 3. Yeah. So it would be like 3 comma 4 pi over 3, 2 comma 4 pi over 3, and so on and so forth. And basically you're just plotting out points like this. So I drew this circle, and so it's on 4 right now. So if I were to draw the lines that were to go from 1 to 3, it would be 3, what was it, 4 pi over 3. So here, let me draw that. On that picture, it just shows it on the bottom.
Mm-hmm.
On that graph.
So it's that same. Okay, that makes sense. Because theta is not changing. It's just that R value that's changing.
Yeah.
Along that pole.
So it basically look like that.
Okay.
I don't know if that makes any sense, but they just all go through 4 pi over 3, but it's plotted
Going through all of the
Yes.
different range.
Yeah, going through basically 2, 3, or 1, 2, 3, and 4 is what I had on that paper.
Okay. That makes sense. So you graphed it, and then we just need to name the two other polar coordinates. And can we figure it out with the graph?
Oh yeah, so basically it's this. So that's what the graph is saying.
Oh, okay. That makes sense. Cool. Thank you. You're awesome.
I would have never gotten that.
Yeah.
And I think so on the homework it's just have you guys done all the homework yet?
No, I still have to do a part of it.
I still have there are questions. I just like leave certain questions that I couldn't get right away, and I just have to go back in today and do all those.
So I know that if you on the homework there's like on the top right of it there's like an example of how to do it, and that's basically how I get my notes. I just basically I get the what's it called, the snipping tool on my computer, and I just copy and paste it onto a Word document. And so, but on there's all those examples, and when you get I think it'll have you like choose graphs. Basically you want a line that goes all the way up and down, and that's basically what those points are. You can go all the way up and down the graph as long as you use the pi value that they give you.
Okay. That makes sense. Cool. So I think that was the last question, right?
Yep.
Yeah.
All right. I don't know if we have to turn in the video for this. Do you know?
I've never had.
Because we already did the participation points and the video for the second hangout.
I can put it underneath like comments. I know when you're turning in, there's comment section there.
Okay. So I'll just
put it in there.
Post the video on the Google chat and then
Okay.
on there.
Yeah, and I'll upload it right now. I have my printer here. We're set up now.
Okay. Good.
Yeah.
All right. Perfect. All right. Thanks, guys.
Yeah.
Have a good one.
Bye.
Bye.